and welcome to another class of applied thermodynamics tutorial. I am Thananga Zutia, and today we will discuss questions that were taught in the theoretical classes in the previous year. So let me share the screen first. Yeah, okay, I hope you can see the screen now. Okay, so let us start. The first question is, if the largest volume capacity of combustion chamber before the compression stroke is 75% larger than the smallest capacity after the stroke, determine the compression ratio. So before that you have to learn something like, if this is my combustion chamber, okay, this is my combustion chamber, okay. So in the combustion chamber, what happens, there is some piston, okay, which reciprocates this direction, okay, which reciprocates in this direction, and there is some minimum and maximum limit. So this limit is called your TDC, okay, and this limit is called your BDC, where TDC stands for top, dead, center, and BDC stands for bottom, dead, center. Okay, this means what, that this piston will go and it can go up to maximum at this point, okay. After this point it won't go. So what happens, there is some amount of volume of air is always left there. So this volume of air is basically we call clearance volume, or VC, okay. And in going from this from BDC to TDC, it also sweeps some amount of volume. So this amount of volume is known as either displacement volume, or sometimes we call VD, or it is known as swept volume, okay, VS. In both terminologies is the same. So now what it is telling us, that the largest volume capacity of the combustion chamber before the compression stroke. So before the compression stroke, volume before compression, what would be the volume before the compression? This would be nothing but VC plus VS. Yes or no? Because the piston was at this position, at the BDC, okay, and at the BDC the volume is nothing but the VC plus VS, okay. After compression, volume after compression is equal to what? VC, because after compression what happens, now my piston moves to TDC. So after it moves to TDC, now only the VC amount of volume is left. So volume after compression is VC. Now according to definition, therefore compression ratio is defined as the ratio of volume of the cylinder before compression to the volume of the cylinder after compression, okay. So compression ratio is basically defined as the volume of the cylinder before compression and volume of the cylinder after compression, okay. So therefore compression ratio that is CR will be equal to what? Volume before compression by volume after compression. Okay, and what is the volume before compression is Vc plus Vs, and volume after compression is Vc. Okay, now what it is telling us, that there is one relationship is telling us. Okay, so this, if I name this Vc plus Vs as say one terminology V total. Okay, according to question, V total is 75% greater than Vc. Okay, so V total is 75% greater than Vc. This means what? V total is nothing but Vc plus 75 by 100 into Vc, which will be nothing but 1.75 times Vc. Okay, so therefore compression ratio CR is now V total divided by Vc, and what is V total? My 1.75 Vc divided by Vc, so which will give you the compression ratio as 1.75. So option A is the correct answer. Okay. Fine. So let us go to the next question. A 4-cylinder spark ignition engine is designed for compression ratio 10 with a swept volume of 0.0030 meter cube for a square engine, and calculate the bore, stroke, and the clearance volume of the engine. Okay, so again I'm just showing this without drawing the piston. Okay, there will be one bottom dead center, there will be one top dead center, and above that top dead center, whatever volume is there, this volume is basically my Vc. Okay, and this part is actually called bore. Okay, the diameter of that cylinder. Okay, this part is called a bore, and this part is called stroke. Sometimes they also write this as L also. Okay, stroke length from TDC to BDC, that length is basically, if this is my BDC, I'm sorry, let me draw. Okay, so this is what is called stroke volume, stroke. And if I'm looking at this volume part, okay, this volume is basically my swept volume. Sometimes this is also written as S and VD. Okay, so now what is given to us? Given compression ratio is equals to 10. Okay, and Vs is equal to 0.0030 meter cube. Okay, now since it is a square engine, okay, now there are different types of engine depending on the relationship between bore and the stroke length. Okay, bore diameter and the stroke diameter. Okay, so if these two are equal, since it is a square engine, therefore bore is equals to stroke. Sometimes it can also be written as L. Okay, in some of the questions you will also find it as L, so just don't confuse it. Okay, now remember, this is the swept volume of a 4-cylinder engine. Okay, this is the swept volume of a 4-cylinder engine. So therefore pi by 4 into, okay, let me write this first. Therefore volume swept by 1 cylinder will be equal to what? Pi by 4 times diameter square into the stroke length. Okay, therefore volume swept by 4 cylinders. Okay, now this will be, I can write this one as pi by 4 times b cube, since S is equals to b. So this will be what? 4 into pi by 4 into b cube. So this I can write as pi into b cube. Okay, so this is the volume swept by 4 cylinders. Okay, so therefore According to question, what it is telling us that this volume swept by the 4 cylinders is equal to your 0.0030, and from here B will be nothing but 0.0030 divided by pi to the power 1 by 3. Okay. So this will be equal to 0.009847 meter, which I can also write as, sorry, it's not 0.00, it's 0.09847 meter. This can also be written as 98.5 millimeter. Okay, fine. So what you have got the bore length. Next is you have to find the stroke. What is the stroke? Stroke is nothing but equal to bore, and that is also equal to 98.5 mm. Okay, next is find the clearance volume. Okay, so next is clearance volume. So how will you calculate the clearance volume? Compression ratio, we know it's volume before compression divided by volume after compression. Okay, so what is volume before compression is Vc plus Vs, and volume after compression is Vc, and this can be written as Vs by Vc plus 1. Okay, so therefore Cr minus 1 is equal to Vs by Vc. So this gives Vc equals to Vs divided by compression ratio minus 1. Now what is your swept volume? What is your swept volume? It's 0.0030. And what is your compression ratio? 10. But remember, this is the swept volume for 4 cylinders, so this will be divided by 4. Okay, so divided by 4, and it will be 10 minus 1. Okay, so clearance volume of one cylinder, 0.0030 divided by 36. So this will be equal to 8.33 into 10 raised to the power minus 5 meter cube. Okay, fine. Clear? Okay, so now let's go to the next question. The capacity of a 4-stroke over square spark ignition engine is 250 cc. The over square ratio is 1.2, and the clearance volume is clearance volume of the engine is 26 cc. Cc is nothing but centimeter cube. So you have to calculate the bore stroke compression ratio of the engine. Okay, once again a simple question. So the capacity of a 4-stroke engine, so basically it is telling us Vs is equals to 250 centimeter cube. Okay, so this is the stroke capacity. Okay, and it's a 4-stroke engine, and it's a 1-cylinder engine, so it is all about this engine. Okay, the over square ratio. Now before it was square. Now bore to stroke ratio is given to us as 1.2. okay, and what it is telling us that the clearance volume is 26 centimeter cube. okay, now from here you have to calculate the bore, the stroke, and the compression ratio. okay, so how will you calculate now? First of all, the compression ratio is what? Vs plus Vc by Vc. okay, which all values we all already know. So this will be nothing but 250 plus 26 divided by 26. okay, .61 is the compression ratio. okay, now next is what we know, Vs is equal to pi by 4 times B square into S. okay, Vs is equal to pi by 4 times, now what is B? B is nothing but 1.2 times S whole square into S. okay, so Vs will be equal to pi by 4 into 1.2 square into S cube, and from here S will be nothing but 4 into Vs divided by pi into 1.2 whole square to the power 1 by 3. okay, so what is your Vs? 4 into 250 divided by 4 into 250 divided by pi into 1.2 whole square to the power 1 by 3. okay, this will be equal to your 6.046 centimeter. So this is your stroke. Now then calculate the bore. Bore is equals to 1.2 times S, so that will be 1.2 into 6.046 centimeter. .2552 centimeter. okay. okay, so now let us go to the next question, which is a bit longer question. okay, an automobile has a 3-liter SI V6 engine that operates on a 4-stroke cycle at 3600 rpm. The compression ratio is 9.5. The length of the connecting rod is 16.6 centimeter, and the engine is square. At this speed, combustion end 20 degree after TDC. ATDC means after TDC, and you have to calculate the cylinder bore and stroke, the average piston speed, the clearance volume of each cylinder, the piston speed at the end of the combustion, and the volume in the combustion chamber at the end of the combustion. okay, so basically for doing this question you have to know certain things. okay, till now we know this part. okay, till now we know this part, that if this is a piston, so this is my BDC, this is my TDC, okay, and this is my bore, okay, and this is my stroke, okay, which I can sometimes call as L. Now this piston it is basically run through a crankshaft mechanism. Okay, so this is, if this is a crank, okay, this and this are basically connected by the connecting rod. This is called your connecting rod, okay, and this angle, if it is theta, so certain notations are there which you should understand. This distance is A, this distance is R, and this distance, if we take it as X. Okay, so usually what happens, stroke length is equal to your S, and this stroke length will be nothing but 2 times of A. Yes or no? Because this radius, whatever radius of this crank will be, it will be 2 times of this. Okay, so crank offset, this A is called crank offset. Okay, this is A and this is equals to your S by 2. Fine. Now there is some non-dimensional parameter R. Okay, this is non-dimensional, capital R, that is nothing but small r by A. And what is R? R is length of connecting rod. Okay, so R is length of the connecting rod. So now from here you can calculate distance between crank axis and wrist piston is equal to X, and that is equals to your A cos theta plus root over R square minus A square sin square theta. Okay, so therefore instantaneous can you mute yourself? Hello. Hello, can you mute yourself? Hello. Yeah, thank you. Okay, so from here then what we can calculate, instantaneous speed of the piston. Okay, at any instant you have the instantaneous distance, so instantaneous speed of the piston, if I mention this as UP, that will be equal to nothing but dx by dt. Okay, again average speed of the piston UP bar is equals to 2 into stroke length into number of revolutions. Okay, so this is your RPM of the crank. Okay, next, so then there is a relationship in non-dimensional form which is very easy to solve. Okay, in non-dimensional form, UP divided by UP bar is equals to pi by 2 times sin theta into 1 plus cos theta divided by root over R square minus sin square theta. Okay, similarly for instantaneous volume we can write this V by Vc is equals to 1 plus 1 by 2 times compression ratio minus 1 into R plus 1 minus cos theta minus root over R square minus sin square theta. Okay, so these are the various formulas which will be basically helpful in solving this type of questions. Okay, now first part, we have to calculate cylinder, bore and stroke. Okay, fine. Oh, before that I have not written the given things. Let me write it once again. Okay, what it is given: total number of engines is equals to 6. Okay, not engine, actually it should be cylinders. So total number of cylinders is equals to 6. Okay, total swept volume is equal to what? Total swept volume is given as 3 liter. Okay, 3 liter, which can also be written as 3000 centimeter cube. Okay, and N, that is RPM of the engine, is given as 3600 revolutions per minute. Compression ratio is given as 9.5. Theta is given as 20 degree. Length of the connecting rod is given as 16.6 centimeter, and the engine is squared, so therefore B is equals to S. Okay, since the engine is square. Okay, so these are the things which are given. Now what you have to calculate: cylinder, bore and stroke. Okay, displacement volume of each cylinder. So what will be the displacement volume of each cylinder? There are 6 cylinders and the total swept or displacement volume is 3000 centimeter cube. So displacement volume of each cylinder will be nothing but 3000 by 6 centimeter cube, which is equal to 500 centimeter cube. Okay, now displacement volume of each cylinder can also be written as Vs is equal to pi by 4 into B square into S. Yes or no? Pi by 4 into B square into S. Now since B is equals to S, so this can also be written as pi by 4 times B cube. So therefore pi by 4 times B cube is nothing but 500, and from here B is equals to 500 into 4 divided by pi to the power 1 by 3, and this you will get it in centimeter. Okay, this you will get it in 8.6 centimeter. Okay, therefore your stroke will also be equal to 8.6 centimeter. Clear? Next, what you have to calculate: average piston speed. Okay, average piston speed. So what I have given you, I have already given you the predefined formula for the average piston speed, that is UP bar. Okay, so average piston speed UP bar is equals to 2 into S into N. Okay, 2 into S is 8.6. This is in centimeter, so I will convert it into meter, and this is what 3600 revolutions per minute, so I will convert it into revolutions per second, so that I will get the entire speed in meters per second. Okay, 8.6 into 3600 divided by 1000 into 60. So that is equal to your 10.32 meters per second. Okay, so this is your average piston speed. Next, clearance volume of each cylinder. Clearance volume of each cylinder. Okay, now we have the compression ratio is equals to, what is the compression ratio they are given? 9.5, and we also know that the compression ratio is nothing but Vs plus Vc upon Vc, which will be equal to Vs by Vc plus 1. So from here Vc will be equal to Vs divided by Cr minus 1. So do we know the Vs for each cylinder? We know the compression ratio. Okay, and so from here, this will look like square. So from here we will get the clearance volume of each cylinder. So Vs will be what? Vs of each cylinder is what? 500. Okay, and the compression ratio is 9.5 minus 1. Okay, (58.82 centimeter cube). Okay, fine. Next, piston speed at the end of the combustion. Piston speed at the end of combustion. Okay, so at the end of combustion, your theta is equal to 20 degrees given. So that means at that instant, so that means you have to calculate, therefore we need to calculate UP at theta equals to 20 degree. Why? Because at the end of the combustion, theta is equals to 20 degree angle is given. So we know a formula of x, and we can do dx by dt of that, and we can solve for that question. But what happens, you know, the expression becomes too tedious to solve. So for that, there is a non-dimensional equation of u p by up bar. Okay, and that is equal to pi by 2 into sine theta, pi by 2 into sine theta, okay, into 1 plus cos theta divided by root over r square minus sine square theta. Okay, so from here we know the UB bar value, which will be mean value, which is constant. Okay, so from here we can calculate the entire stuff. So this will be what? Pi by 2 into sine 20 degree plus 1 plus cos 20 degree by, now what is r? R is equal to r by a, small r by a. Okay, small r divided by a. Small r is equals to length of the connecting rod, and which we already know as 16.6 centimeter. Okay, what is a? A is equals to s by 2. And what is s? S is 8.6 centimeter divided by 2, so that will be equal to 4.3 centimeter. Okay, 4.3 centimeter. So therefore my r will be what? 16.6 divided by 4.3 This is 3.86. So R is equals to my 3.86. So this will be 3.86 whole square minus sine squared 20 degree. Fine. Can you quickly do the right hand side? Cos 20 divided by root over 3.86 whole square minus sine 20 whole squared, okay, plus 1 into 0.5 into pi into sine 20, okay. So this is your 0.66854, okay. So therefore UP is equals to UP bar into 0.66854, okay. What is my UP bar? 10.32, okay. So you'll get your answer as 10.32 into 0.66854 meters per second, which will be equal to 6.899 meters per second, okay. So this is your velocity or speed of the piston at the end of the combustion, okay. So this is your piston speed at the end of combustion, okay. Next, what we should find is the volume in the combustion chamber at the end of the combustion, okay. Yes, volume in the combustion chamber at the end of combustion, okay. So that means now, therefore, we need to find V at theta is equals to 20 degree. Why? Because we know that there is a formula for instantaneous volume, and in this case at the end of the combustion, and which is a function of the angle theta. So at the end of the combustion, the theta that is being created by the crank is equals to 20 degree, okay. And here also we have a non-dimensional equation, this one, okay. So therefore V by Vc will be equal to what? 1 plus 1 by 2 times Cr minus 1, okay, into R plus 1 minus cos theta minus root over R square minus sine square theta, okay. Just put it here. So what you will get, V upon Vc will be equal to 1 plus 1 by 2 times, what is the compression ratio? 9.5 minus 1, okay. What is the R? 3.86 plus 1 minus cos 20 degree minus root over 3.86 whole square minus sine squared 20 degree, okay. So V by VC is equals to 1.32083. Okay, so from here V is equals to 1.32083 into VC. And what is your VC? 58.82. Okay, 1.32083 into 58.82 centimeter cube. Okay, this will be your 77.69 centimeter cube. Okay, so what is this? This is volume in the combustion chamber after the compression. Okay, fine. Okay, so let us go to the next question then. An automobile engine has a 3-liter SI V6 engine that operates on a 4-stroke. Compression ratio is 10.5. Length of the connecting rod is 16 cm and the engine is squared, just like the previous question. At this speed, combustion ends at 20 degree after the TDC. It is connected to a dynamometer which gives a brake output torque reading of 200 Newton into meter at 3600 RPM. Mechanical efficiency is 85%, and you have to calculate the clearance volume of one cylinder, the piston speed at the end of the combustion, the volume in the combustion chamber at the end of the combustion, the brake power, the indicated power, the brake mean effective pressure, indicated mean effective pressure, the friction mean effective pressure, and the power loss due to friction. Okay, so the first part, that is the clearance volume of one cylinder, the piston speed at the end of the combustion, and the volume of combustion chamber at the end of the combustion. These are basically the previous questions only. Okay, so I will not waste so much time, so just quickly I will write it. Solution: given what it is given, number of engines, I'm sorry, it's basically cylinders, number of cylinders is equals to 6, total displacement volume is equals to what? 3 liter, and that is equals to your 3000 centimeter cube. Okay, compression ratio is 10.5, length of the connecting rod 16 centimeter, theta 20 degree, B is equals to S, and N is equals to 3600 RPM. So what are the new things that are given? Torque tau is equals to 200 Newton into meter, and eta mechanical efficiency is given to us as 85%. Okay, so first of all we have to calculate the clearance volume of one cylinder. Okay, so Vs of one cylinder is equals to what? 3000 by 6, that is 500 centimeter cube. Okay, compression ratio is equals to 10.5, and we also know that the compression ratio is nothing but Vs plus Vc by Vc, which will be equal to Vs by Vc plus 1. So from here Vc will be equal to Vs divided by Cr minus 1. So what is your Vs? 500, Cr 10.5 minus 1. Okay, that is equal to your 52.63 centimeter cube. Okay, So this is your clearance volume of one cylinder. Okay, next is piston speed at the end of combustion stroke. Oh, I have written false here, so this is at the end of combustion. Okay, okay, fine. This is again similarly we know, so we have to calculate up at theta is equals to 20 degree. We need to calculate. Okay, and for this we know that up upon up bar, okay, is equal to what? Pi by 2 times sin theta into 1 plus cos theta divided by root over r square minus sin square theta. Okay, so for this we need to know what is up bar. So up bar is nothing but 2 into s into n. So again for this what we need to know s. Okay, so for s what we have to do, pi by 4, remember your vs is equals to pi by 4 into b square into s, and since here b is equals to s, so that is equals to pi by 4 into b cube, and this is equal to, and vs is equal to your swept volume is 500 centimeter cube. So therefore pi by 4 into b cube is equal to 500, and from here b is equals to 4 into 500 divided by pi to the power 1 by 3. Okay, four into 500 by pi to the power 1 by 3, and that is equal to your 8.6 centimeter. Okay, and since b is equals to s, so therefore s is also equals to your 8.6 centimeter. Okay, so now this s we will put it here. Okay, so 2 into 8 point, let me write it again, up bar will be equal to 2 into 8.6 divided by 100, and into your n is given as 3600, 3600 divided by 60, so this will be all in meters per second. Okay, so this is 10.32 meters per second. So you got up bar. Now what you need, you already have theta, so now you just need r. Okay, what we know, r is equals to small r divided by a. Small r, it is the length of the connecting rod, which is given as 16 centimeter. And what is a? A is nothing but s divided by 2. You have s, so that is 8.6 divided by 2, so that means 4.3 centimeter. So therefore your r will be nothing but 16 divided by 4.3, and that is equal to 3.72. Okay, so now we can put it in the formula. Okay, so up by up bar, that will be equal to pi by 2 times sin theta into 1 plus cos theta divided by root over r square minus sine square theta. Okay, so that is equals to pi by 2 sine 20 into 1 plus cos 20 divided by root over 3.72 whole square minus sine squared 20. Okay, so u by up by up bar will be equal to what? 1 plus cos 20 by root over 3.72 whole square minus sine 20 whole square 0.5 into pi into sine 20. Okay, so this is equal to your 0.6735. okay, so from here up is equals to up bar into 0.6735. okay, what is up bar? 10.32 into 0.6735 meter per second. This will be equal to your 6.95 meters per second. Okay, what is this? This is basically speed of piston at the end of combustion. Okay. Speed of the piston at the end of combustion. Okay, next is what? Volume in the combustion chamber at the end of the combustion. Okay, so volume in the combustion chamber at the end of combustion. Okay, so once again we know V by Vc is equal to what? 1 plus 1 by 2 times compression ratio minus 1 into r plus 1 minus cos theta minus root over r square minus sine square theta. Okay, so from here we I think know everything, that Vc also we know, Cr also we know. So what we'll get? V by Vc is equals to 1 plus 1 by 2 times what is your compression ratio? Compression ratio is 10.5. so 10.5 minus 1. Okay, what is R? R is 3.72 minus cos 20 minus root over 3.72 whole square minus sine squared 20. Okay, so this is equal to your 1.3613. okay, so V is equals to Vc into 1.3613. and what is Vc? Clearance volume 52.63. okay, 52.63 into 1.3613. 3613 centimeter cube. So this is 71.64 centimeter cube. Okay, what is this? This is volume in the combustion chamber after combustion. Okay, next is brake power, that is BP. Okay, so what we know, brake power is nothing but 2 pi into n into tau. Okay, so 2 pi, what is n? N is 3600. Now this is revolutions per minute, so I'll convert it into seconds. Okay, and tau is what? 200 Newton into meter, so this will be getting in watt. Okay, seven 5,398.223 watt, which can also be written as 75.398 kilowatt. Okay, so this is your brake power. Next is indicated power. Okay, so what is indicated power? Brake power is the power that is actually obtained by the engine. Okay, that is the actual output. Indicated power is the maximum possible output that we can obtain. Okay, so there is some loss. The maximum possible outcome, it's like the theoretical possible power that we can produce. So what happens, you know, there is some loss, and due to that loss there is a mechanical efficiency, which is nothing but brake power by indicated power. Okay, the maximum possible power that you can obtain is the indicated power, that is mostly given by the indicator diagram. Okay, now but the brake power is the one which you obtain actually. Okay, so you know the mechanical efficiency is 0.85. okay, brake power you have just calculated is 75.398. okay, so from here your indicated power is nothing but IP is equals to 75.398 divided by 0.85 kilowatt. Okay, that is equal to 88.703 kilowatt. Okay, next is your brake mean effective pressure. Okay, in short form it is written as BMEP. Okay, now suppose this whatever work is done, it is done in terms of some constant volume, constant pressure. Okay, so that work done, if you can convert it into an equivalent work with some constant pressure, PdV work. Okay, that pressure P is nothing but your brake mean effective pressure. Okay, so we know what BP by small n. Okay, what is this small n? I will just let you know, is equals to 2 pi into tau, and that is equals to your brake mean effective pressure into your swept volume, that is the PdV divided by n. Now n is equals to 2 since it is a 4-stroke engine. Okay, so since this is a 4-stroke engine, this n is equals to 2. Okay, okay, and Vs is equals to 3 liter, and in meter cube you can write this one as centimeter cube. It will be what? 3000 centimeter cube, and in meter cube this will be equal to 0.003 meter cube. Okay, so therefore break mean effective pressure will be nothing but 2 pi tau into n divided by Vs. Okay, 2 pi, what is tau? 200, n 2. Okay, what is your Vs? 0.003. I have converted all in terms of meter. Okay, this is in Newton into meter, and this you will get in terms of Pascal. Okay, 2 pi, sorry, 2 pi into 200 into 2.003. Okay, so this is your 837.76 kilopascal. Okay, so this is your break mean effective pressure. Indicated mean effective pressure. Okay, so that is IMEP. Similar to the brake power, you just divide it by the mechanical efficiency. Okay, so IMEP, that is indicated mean effective pressure, is nothing but brake mean effective pressure divided by eta mechanical. Okay, so it's 837.76 divided by 0.85 kilopascal. $985. Okay, next is your friction mean effective pressure, that is FMEP. Okay, so since the frictional power is nothing but brake power minus indicated power minus brake power, therefore frictional mean effective pressure is nothing but indicated mean effective pressure minus brake mean effective pressure. Okay, so that is equal to 985.6 minus 837.76 kilopascal. So that will be equal to your 147.84 kilopascal. Okay, next is power lost due to friction. Okay, so indicated power is the total power that you can obtain. So there is some power loss due to friction which you actually get is as brake power. So therefore your frictional power power lost due to friction is equals to what? Indicated power minus brake power. Okay, so what is your indicated power? $88.703 minus, and what is your brake power? 75 kilowatt. Okay, 13.305 kilowatts. So this much amount of power is lost due to friction. Okay. Fine. Okay, so let us go to the next question then, and in between this any doubt you can just ask. Just I'll wait for 1 or 2 minutes. Okay, now next question is, a certain car requires 15 horsepower to cruise at 65 miles per hour. Okay, so that means in order to attain a speed of 65 miles per hour, the car requires 15 horsepower. The power that is required by the car is 15 horsepower. The energy content of the 1 gallon of gasoline is, if you have 1 gallon of gasoline, then you will get a power of 1.3 into 10 to the power 8 joule. Okay, now if the car gets 40 miles per gallon, so for traveling 40 miles, for 1 gallon it can travel for 40 miles. Okay, so how efficient is the motor? That means you have to find the output energy divided by the input energy. The output energy is your mechanical energy, and your input energy is the chemical energy that is being input by burning the petrol, gasoline. Okay, so what it is telling us, power is equals to what? 15 horsepower, and we know the conversion between horsepower to watt. Okay, and energy content of 1 gallon of gasoline is equals to what? 1.3 into 10 to the power 8 joule. Okay, so 1 gallon of gasoline is this one. Okay, and what it is telling us that since the car gets 40 miles in 1 gallon. Okay, therefore time required to go 40 miles, speed is given as 65 miles per hour. Okay, for this power, this speed is, so time required at this power output, the time required to travel 40 miles will be what? Distance divided by speed. Okay, so that is 40 divided by 65, and this will be in terms of hours. So you have to convert this into seconds. So it will be 40 by 65 into 60 into 60 seconds. Okay, so that will be equal to your 2215.38 seconds. Okay, so this is the time required if you have to attain a speed of, if the car have to attain a speed of if the car have to travel 40 miles distance. So that means you burn 1 gallon. Okay, you burn 1 gallon, you take 1.3 into 10 to the power 8 joule of energy, and you travel 40 miles distance, and for that your time will be this one. So the total energy consumed by car in 2215.38 seconds will be what? It's nothing but power into time. Okay, that will be in joule. So what is your powers? It's in horsepower, so 15 horsepower, and I'll just convert this into watt. That will be equal to 746. Okay, into time 2215.38, and you will get this entire stuff in joule. Okay, 15 into 746 into 2215.38, so that will be 24790,102.2 joule. Okay, so therefore efficiency eta will be what? Energy output by energy input. So you have given total energy of 1.3 into 10 to the power 8 joule, but actually the car consumed 24790,102.2 joule. Okay, so this efficiency you'll get it as 19.06%. Okay, fine. So let us go to the next question then. A 6-cylinder 4-stroke IC engine develops 100 kilowatt of brake power at 800 rpm. The stroke to bore ratio is 1.5. Indicated mean effective pressure is 8 bar. Mechanical efficiency is 80%. Determine the cylinder diameter and the piston stroke of the engine. Okay, so number of cylinders, I is equal to 6. Okay, so it's a 4-stroke engine. Okay, your N is equals to 800, RPM is given. Okay, and what it is given, that stroke to bore ratio, that is L by D, is given as 1.5. Okay, and your brake power, what is your brake power, is given as 100 kilowatt. Okay, and eta mechanical is given as 80%. Okay, so what we know, eta mechanical is equals to brake power divided by indicated power. So from here, indicated power will be equal to brake power by eta mechanical. And what is your brake power? 100, and mechanical is 0.8. So that will be 125 kilowatt. So your indicated power is 125 kilowatt. Now indicated power is equals to what? Number of engines into brake mean effective pressure PM. Okay, and into length into area into small n divided by 60,000. Okay, now N is equals to what? 2, since 4-stroke. Okay, and area will be equal to what? Pi by 4 into d square. Okay, so from here what we will do, IP is equals to I into PM into L is equals to what? 1.5D pi by 4 into d square into N. Okay, so what it is given, brake mean effective pressure PM is given as 8 bar. Okay, divided by 60,000. So from here, indicated power is equals to what? 125 into 60,000. I is equals to 6. Okay, PM is equals to 8 into 10 to the power 5. Okay, so this is your PM into 1.5 into d cube into pi into 2. Okay, so from here, d is equals to what? 125 into 60,000 divided by 6 into 8 into 10 to the power 5. Okay, into 1.5 into pi into 2 to the power 1 upon 3. Okay, this n is equals to I'm sorry, this n is nothing but this is, wait a minute, n is equals to 800 by 2, that is 400. Okay, so this is your 400 and this is your 400. One 25 into 60,000 into 4, 6 into 8 into 10 to the power 5 into 1.5 into pi into 400. Okay, to the power 1 upon 3. So this one you will get as 0.149 meter or 149 millimeter. Okay, so this is your d, this is your cylinder diameter. Therefore cylinder diameter is equal to 149 millimeter. Okay, next is what? Piston stroke. Therefore piston stroke, that is L, is equal to 1.5 into D, that is 1.5 into 149 millimeter. Two 23.5 millimeter. Okay, fine. Let us go to the next question then. From a test on a 4-stroke petrol engine, the following data is available. Engine speed is 1000 rpm, net brake torque is 70 newton into meter. Indicated mean effective pressure is 10 bar. Stroke length is 150 millimeter. Bore diameter is 100 millimeter. Rate of fuel consumption is 2.57 kg per hour, and calorific value of the petrol is 41,000 kilojoule per kg. Calculate the indicated thermal efficiency, brake thermal efficiency, and the mechanical efficiency. Okay, so what it is given, n is equals to 1000 rpm. Okay, and number of engines, I is equals to 1. Okay, and small n will be equal to now n by 2, since it is a 4-stroke engine, so that will be equal to 500 cycles per second. Then what it is given, brake torque tau is given as 70 newton into meter. Okay, and mean effective pressure is given as 10 bar. Okay, stroke length L is given as 150 millimeter, and bore diameter D is given as 100 millimeter. Okay, rate of fuel consumption, that is m dot f, is given as 2.57 kg per hour, and calorific value of the fuel is given as 41,000 kilojoule per kg. Okay, so we know what we know. Indicated power is equal to I PM LAN divided by 60,000. Okay, so I is equals to 1. What is PM? 10 into 10 to the power 5. Okay, so this is in Pascal I have written. Okay, L 0.15. Okay, bore diameter is 100 mm, so pi by 4 into 0.1 whole square. Okay, and your n is 500. Fine, divided by 60,000. Okay, so this you will get it in 9.82 kilowatt. Okay, so that is your indicated power. Brake power in terms of kilowatt will be what? 2 pi n into tau divided by 60,000. Okay, 2 pi, what is your n? 1000 into tau, 70 newton into meter, divided by 60,000. Okay, so this you will get as 7.33 kilowatt. So therefore mechanical efficiency will be equal to what? Brake power by indicated power. Okay, so brake power is 7.33, indicated power is 9.82, so you'll get your mechanical efficiency as 74.64%. Okay, now brake thermal efficiency. Next is brake thermal efficiency. Okay, so eta brake will be equal to what? Brake power divided by mass flow rate of the fuel into calorific value. Okay, So brake power is given as 7.33. Okay, and mass flow rate of the fuel in kg per hour it is given, so I have to multiply by 3600 to make it in kg per second. Okay, and that is given as 2.57, and calorific value is 41,000. Okay, so it is equal to 25.04 percentage. Okay, that is your brake thermal efficiency. Okay, next is indicated thermal efficiency. Okay, indicated thermal efficiency. Fine. So eta indicated, that will be equal to nothing but indicated power divided by mass flow rate of the fuel into calorific value. Okay, so similarly this will be equal to 9.82 3600. Why it is done? Because it's kg per hour, so 2.57 into 41,000. Okay, so this is equal to your 33.55 percentage. Okay, so this is your indicated thermal efficiency. Clear? Fine. So let us come to the next question. A 4-stroke diesel engine has a bore of 100 mm and a stroke of 120 mm, piston speed 10 meter per second. The engine develops 20 kilowatt power per liter of the cylinder stroke volume. Brake thermal efficiency of the engine is 30% with the fuel having a calorific value of 40 megajoule per kg, and your specific gravity of the fuel is 0.90. Determine the RPM, brake power and engine fuel requirements in liters per hour. Okay, so your D is given as 100 mm and stroke length L is given as 120 mm. Okay, piston speed is given as 10 meters per second, that is the average piston speed. Brake power kilowatt per liter of cylinder stroke, and eta brake is given as 30%, and CV is 40 megajoule per kg. Okay, and space density is 0.9 into 1000 kg per meter cube. Okay, now we know UP average is equals to 2 into L into N, divided by 60. So from here n will be nothing but 60 into s divided by 12. Okay, so this will give you 60 into 10 divided by 2 into 0 0.12, 2500 rpm. Okay, so we got the rpm as 2500. Next is what? Stroke volume of the cylinder. Okay, so that will be pi by 4 d square into L. Okay, and this is what? Pi by 4, d is what? 0 0.1 whole square, L is 0 0.12. Pi by 4 d square into L, so pi by 4 into d square into L, so this will be equal to your 0 0.942 liters. Okay, now this is the power per liter. Okay, this is brake power per liter, so therefore brake power will be what? 20 into 0 0.942 kilowatt. Okay, that is 18.84 kilowatt. This is your brake power. Okay, next is your this is your brake power. So now eta brake is what? Brake power into 3600 divided by mass of the fuel into calorific value. Okay, so brake thermal efficiency is given to you as 30%. Okay, so that means this will be 0 0.30. What is your brake power? It is 18.84. Okay, this is 3600. Mass flow rate of the fuel is unknown, and this is your calorific value, which is 40 megajoule, I think. So that will be 40,000. Okay, so remember this 3600 I have multiplied, so this will, you will obtain this one in kg per hour. Okay, so mass flow rate of the fuel will be equal to 18.84 into 3600 divided by 0 0.30 into 40,000 kg per hour. Okay, so you'll get your mass flow rate of the fuel will be equal to 5.65 kg per hour. Okay, Okay, let us go to the next question. The power output of a 6-cylinder 4-stroke engine, diesel engine, is given by a law which is equal to BL into N by 20,000 kilowatt, where BL is the brake load, and in Newton, and N is the speed in revolutions per minute. The bore and the stroke of the engine are 90 and 120 mm respectively. Fuel consumption is 5 centimeter cube per second, and density is 800 kg per meter cube. So determine the following: the brake power, the torque, and the brake specific fuel consumption if the brake load is 600 Newton and the speed of the engine is 2000 rpm. Okay. Okay, so first of all, let us see what is given to us. So you have given a brake power formula, okay, BL into N divided by 20,000, and this will be in kilowatt you will get. Okay, where BL is nothing but brake load in Newton, and N is your speed in rpm. Okay, so given is I, that is the number of cylinders, is 6. Okay, and what it is telling us, it's a 4-stroke engine, so N will be equal to basically N by 2. That is what the thing. The bore diameter is given to us as 90 mm. Okay, and your stroke length is given as 120 mm. Okay, one more thing is given to us as the volumetric flow rate of this steam is given to us. Not steam, the fuel volumetric flow rate of the fuel is given to us as 5 centimeter cube per second. Okay, and another thing that is given is your density. So this you can convert this one in meter cube per hour also. So it will be nothing but 5 into 3600 divided by 10 to the power 6 centimeter cube meter cube, yeah, 10 to the power 6. So this will be in meter cube per hour. Okay, because we will be converting everything in our SI unit. So what you will get, the mass flow rate of the fuel will be nothing but volume flow rate of the fuel into density, and density of the fuel is given to us as 800 kg per meter cube. Okay, so if you put this all values, you will get this one as 14.4 kg per hour. Okay, now it is given to us that the brake load is equals to 600 Newton. BL is equals to 600 Newton. Okay, and our N is equal to 2000 rpm. Okay, so then what is the brake power? It's very simple, BL into N divided by 20,000. Okay, so BL is 600, N is 2000, and this is 20,000. So this is your 60 kilowatt. Okay, this is very simple. The first part is very simple. Okay, next is you have to determine torque. Okay, so we know brake power is nothing but 2 pi into N into tau divided by 60,000 if you express everything in kilowatt. Okay, and this tau is in Newton per meter. So we got your brake power as 60. Okay, 2 pi, what is your N? N is 2000, tau is not known, and this is divided by 60,000. Okay, in doing this you will get your tau, and this tau 60 into 60,000 divided by 2 pi into 2000. Okay, So you'll get your tau as 286.47 Newton into meter. Okay. Next is your brake specific fuel consumption in and this is nothing but the MF. Okay, your brake specific fuel consumption. Brake specific fuel consumption. Okay, sorry. So your brake specific fuel consumption is equal to mass flow rate of the fuel divided by brake power. Okay, so your mass flow rate of the fuel is, you got it as 14.4. okay, and this is you got as 60. 14.4 it was kg per hour, and this is your kilowatt, so you will get this in kg per kilowatt hour. Okay, 0.24 kg per kilowatt hour. Okay, so let us go to the next question then. A 4-cylinder 2-stroke petrol engine with a stroke to bore ratio of 1.2 develops 32 kilowatt at 2500 rpm. The mean effective pressure of the piston is 8 bar and the mechanical efficiency is 85%. Determine the diameter and the stroke of each cylinder. The brake thermal efficiency if the fuel consumption is 9 kg per hour, having a calorific value of 44,000 kilojoule per kg. Okay, so here again the number of cylinder I is equals to 4. Okay, it is a 2-stroke petrol engine. Okay, then what it is given that the stroke to bore ratio, that is L divided by D, is equals to 1.2, and it develops a brake power of 32 kilowatt. Okay, and your N is given as 2500 rpm. Okay, mean effective pressure PM is given as 8 bar. Okay, and your mechanical efficiency is given as 85%, which we can write as 0.85. Okay, so what we have to determine: number 1, diameter and stroke of each cylinder. Okay, that means your D and L of each cylinder you have to determine. Okay, what we know, eta mechanical efficiency is equals to brake power divided by indicated power. So from here, indicated power will be equal to brake power divided by eta mechanical. What is your brake power? 32, and mechanical efficiency is 0.85. So you put it, you will get this one as 37.65 kilowatt. Okay, so this is your indicated power. So we know indicated power is equals to what? I PM len divided by 60,000. Now what is N here? N is equal to your N by 2. Since this is a sorry, here N will be equal to N because it's a 2-stroke engine, so nothing will be changed here. Here N is equals to N since 2-stroke. So in 4-stroke, its N is equals to N by 2. Okay, so indicated power we know 37.65. I is equals to 4. PM is equals to 8 into 10 to the power 5 Pascal. L and D we have to determine. So from this expression, I will express L in terms of D. So this will be equal to 1.2 into D. And what will be your area? Area will be pi by 4 into D square. Okay, and N is equals to 2500. Yes, N divided by 60,000. And from this you will get your D will be equal to 0.00669 meter, or we can write this one as oh, too much of zeros, sorry. So you will get 0.0669 meter, and that is equals to 66.9 millimeter. Okay, so therefore L is equals to 1.2 into T, and that will be equal to 80.3 millimeter. Okay, so the stroke and the bore we have calculated. Now the brake thermal efficiency. Number B, brake thermal efficiency. Okay, so eta brake is equals to what? Brake power divided by mass flow rate of the fuel into calorific value of the fuel. Okay, so fuel consumption rate, mass flow rate is given in kg per hour, and this is in calorific value. Calorific value is 44,000, so everything is given. So we know the brake power. What was your brake power? Brake power was 32. Okay, and mass flow rate is given in 9 kg per hour. Okay, 9 kg per hour, so you will divide it by 3600, so you will get it in kg per second, and this is calorific value of the fuel is given to you as 44,000. Okay, so from this you will get your brake thermal efficiency is 29.1%. Okay, fine. Okay, so let us come to the last question of today's part. So the following results are obtained on a Morse test conducted on a 4-cylinder 4-stroke petrol engine at a common constant speed in all cases. The brake power of the engine when all the cylinders are firing is equal to 80 kilowatt, and the brake power of the engine when each cylinder is cut off is in turn is 55 kilowatt, 55.5 kilowatt, 54.5 kilowatt and 55 kilowatt respectively. So, and you have to determine the mechanical efficiency when all the cylinders in the firing. So in a Morse test, what happens? It's a very simple formula that works here. Okay. So indicated power, IP is equal to what? BP plus FP. That is, indicated power is nothing but brake power plus frictional power, because indicated power is the maximum power and that you can obtain, but actually you obtain brake power because some amount of power is lost in terms of friction. So that's why indicated power is equal to brake power plus frictional power. Now if you assume indicated power as I, brake power as B, and frictional power is F, so this equation becomes this way. So this is I am writing just because we have 4 cylinders, so we will apply this one. Okay, so when all the cylinders are working, so when all the cylinders are working, then 4I is equals to 4B plus 4F. Yes or no? Because all the cylinders are working. Okay, now when one cylinder is cut one by one, okay, then what will happen? 4 different reading is taken. Okay, for 3 working cylinders, and then the average value will be 3B is equals to 3b1 plus 3b2 plus 3b3 plus 3b4 divided by 4. Okay, so where 1 is the case when one cylinder is cut off, the 2 is the case when the 2 cylinder is cut off, and so on and so forth. So for the 3 cylinders, for 3 working cylinders, okay, what will be the formula? If 4 working cylinders, formula is 4i is equal to this one, so 3 working cylinder formula will be 3i is equals to 3b plus 3f. Okay, so from here but can you if you cut off this, you will not be able to compensate, or you will not be able to minimize the frictional loss. Okay, so frictional loss will always be present there. Okay, so therefore my indicated power I will be nothing but, means if you subtract this equation 1 and equation 2. Okay, so if I name this as equation 1 and if I name this as equation 2, so equation 1 minus equation 2 will be equal to I is equals to 4b minus 3b. Okay, so therefore 4i is equals to 4 into 4b minus 3b. Okay, now what it is given us, given 4b, that means all the cylinders are working, then my brake torque is given as 80 kilowatt. Okay, b1 is given as 55 kilowatt, b2 is given as 55.5 kilowatt. Okay, b3 is given as 54.5 kilowatt, and my b4 is given as 55 kilowatt. Okay, therefore 3b is equals to 55 plus 55.5 plus 54.5 plus 55 divided by 4, that will be equal to 55 kilowatt. Okay, so therefore I is equals to 4b minus 3b. Okay, so what is 4b? 80, and what is 3b is equals to 55 kilowatt. Okay, so that is 25 kilowatt. Okay, and therefore my 4i is nothing but 25 into 4, and that is 100 kilowatt. Okay, so therefore eta mechanical efficiency will be equal to what? Net BP divided by net IP. That means the 4 cylinders, if you work together, this is given as 80 kilowatt, and this is, we have just now calculated, is 100 kilowatt, so this will be nothing but 80%. Okay, fine. Okay, so with this I conclude today's class, and we'll meet you in the next week. Thank you.